Today, we want to look at the general revision on mathematics. And this class is meant for those who are sitting on examination or the other, and likewise, anyone who wants to improve in their mathematics skills will still benefit from here. So stay tuned and watch what we have for you here today. Now, we want to solve these particular questions. Number one, we have multiply 2.7 times 10 raised to the power minus 4 by 6.3 times 10 raised to the power 6, and leave your answer in standard form. Leave your answer in standard form. So this actually is a simple question. So what we have solution here, we want to multiply these two numbers. Actually, this is also in standard form. We have 2.7 times 10 raised to the power minus 4, then multiply by 6.3 times 10 raised to the power 6. But to leave our answer in standard form. Now, to multiply, we separate the decimal number. As we have 2.7 times 6.3, then multiply by 10 raised to the power minus 4 times 10 raised to the power 6. So normally we multiply this. We can do that without calculator. First, we can do away with decimal. 27 times 63, then 3 times 7, 21. We keep 2, then 3 times 2, 6, plus 2, 8. Also 6 times 7, that gives us 42. Then also excuse me, we write 2, we keep 4, then 6 times 2, 12, and 12 plus 4, that's 16, and we have 1, 0, 7, then 1. So here we have 1, here that's 10, we keep 1, that's 7, 1. Now, how many number? This is just to show us how to multiply this decimal. We have 2 digits now altogether after decimal. This is 1 digit, they're making 2 digits. So also we are going to count 2 digits after decimal. So our decimal point should be here for this. So what we have now is 17.01 times 10 raised to power. Here we apply the law of indices. When we have a raised to power n times a raised to power n, this is a raised to power n plus n. When you multiply, we have minus 4 plus 6. That is here we now have 17.01 times 10 raised to power minus 4 plus 6. Same thing as 6 minus 4, that's 2. Then, since we want this one to be in standard form, we change that number to standard form. And don't forget that a number that will be in standard form we have to have this digits less than 10. So as we have it as a times 10 raised to power n, where 1 is less or equals to, or let's say 0 is less or equals to a, and a is less than 10. So between actually 1 and 10 now. So we shift this point just one time here. Now we shift this one just once, so that this thing now is already 17 is already more than 10. So we shift this point back once, become 1.701. So the number of times we shift it, multiply by 10 raised to power that time, that's 1. And we already have 10 raised to power 2 here. That is, here become 1.701 times 10 raised to power also 1 plus 2, according to the law of indices. And we have 1.701 times 10 raised to power 3. So this here we have already multiplied these numbers and we put the answer in style form. That's one of the examination question, particularly for the West Africa Examination Council. You are watching us here live at Master Team Class, so share this video, give it a share in hundreds, and also stay tuned. Okay, something interesting. We have so many interesting questions here. So if you are not yet subscribed, subscribe. All right, let's look at the second question here. And this one is simple indica equation. So, and we tag it as question number 2. We're going to say if 9 raised to power 2 minus x is equals to 3, find the value of x, find x. So it's just a simple indica equation, by the way. So when we solve this, we have 9 raised to power 2 minus x equals to 3. We just have to change the base here, which is 9, to 3 as well, so that both sides will have the same base. And we understand that 9 can be written as 3 squared, which is also raised to power 2 minus x equals to, here is already 3 raised to power 1. So here we open this bracket, and this becomes 3 raised to power 2 times 2, that's 4, minus 2 times x, 2x, equals to 3 raised to power 1. So now we can drop the base from when we have a raised to power n equals to a raised to power n. This is m equals to n. So here we can say 4 minus 2x is equals to 1. So now we take 4 to the other side. We have minus 2x left equals to 1 minus 4. And minus 2x equals to 1 minus 1 minus 3. Divide both sides by minus 2. That is, here minus 2 cancel each other. We have x equals to minus cancel minus. We have 3 over 2. So x here equals to 3 over 2. Or we can say whole number 1 over 2. So that's a simple indica equation for that. Now we solve another question here. And this one has to do with number basis. So in what number base is the addition 465 plus 24 plus 225 equals to? So when you look at this, actually, the highest number we have here is 6. So the base cannot be base 6. We can only have it either base 7, either be base 7, base 8, base 9, and so forth. So which base is it? Let's just say we have 4, 6, 5. We have 2, 4, and we have 2, 2, 5. We are adding this. We don't know the base, and we have the result already as 0, 5, 0, 1. Now, if we are going to have 0 here, which base is it done? We have 5. This is 14. 5 plus 5 plus 5. That's 14. Now, don't forget that for us to have 0 here is the remainder. We have 14 divided by the base. Give us something remainder 0. And of course, if the remainder is 0, there is a number that will go in 14 here. That's 7 perfectly. So that will give us 2 remainder 0. So this will be, because this is 14, and we have to divide by the base so that we can have something remainder 0, because this is remainder. Now, what we go in 14 exactly is 7. Of course, that's 2 remainder 0. That's why we have 0 here. Okay. Now, let's test if this 7 is now the base. So we have this 2 will be carried to the next one. Don't forget, this is 6 plus 4, 10 plus 2. Plus this 2 will carry. That's 12 now. Okay. What number is, when we divide it, we are going to have something remainder 5, because this is remainder 5. Of course, when we put the 7 here, that's it's 7 goes there one time. That's 1 remainder 5, which is exactly. So we don't need to work further and stress ourselves. The base here, which is the addition done, is therefore in base 7. So this addition now is done in base 7. So that is the final answer. Okay, let's look at another one. Let's look at another one. You're welcome, and you're watching us live at Master T Class. So do us a favor by clicking the like button, share this video, and subscribe to this interesting channel of mathematics. Okay, now I want to look at another question here, number 4, and it has to do with fraction. So we have to simplify 1 number 7 over 8 times 2 whole number 2 over 5 divided by 6 whole number 3 over 4, then divided by 3 over 4 divided by 3 over 4. Okay, let's look at it here. It's an interesting one actually. So we need to change all the fraction to improper fraction. So we write this now and change it to improper fraction. 8 times 1 is plus 7, that's 15. This becomes 15 over 8 times also 5 times 2, 10 plus 2, that's 12. That's 12 over 5. Then divided by, yeah, 4 times 6, 24 plus 3, 27 over 4. Then divided by, here we have 3 over 4. Now you can handle the numerator and also handle the denominator. Up here, you can say 5 goes here 1 and 5 goes here 3. And 4 goes in 8, 2. 4 goes in 12, 3. So up here we have 3 times 3, 9. That's 9. Then over 2 times 1, 2. Then this long division here, you can still put it that way. Then don't forget division here can change to multiplication. And this becomes 27 over 4 times, if this changes now, to multiplication. 4 will go up, 3 will come down. We have 4 over 3. Okay, and this also 4 cancel each other here. 3 goes here 1, 3 goes here 9. So which makes this fraction to become 9 over 2 divided by, here we have 9 up and we have 1 here. So in another way, you can say this is 9 over 2 divided by 9 over 1. Also, we change this to multiplication. We have 9 over 2 times 1 over 9. Also, 9 cancel each other, and this becomes 1 over 2. So here we have this as the solution to that fractional problem there. All right. So we want to solve another one, and this one is also interesting one, which is on series. I have all the series or sequence. Say sequence now. We have what is called sequence and series. Majorly, we have AP, arithmetic progression. We have also geometric progression. For this one, a pattern has been given. So let's say number 5. The question says if u subscript n is equals to n into bracket n squared plus 1 u subscript 5 minus u subscript 4. Now, solution. Since this is u subscript n, we can substitute when n is equal to 5 to get u subscript 5, and this becomes 5 into brackets 5 squared plus 1 direct. This relation, that's what we have, which makes u subscript 5 equals to 5 into brackets 5 squared, 5 times 5, 25 plus 1. But this is 5 times 25 plus 1, 26. 5 times 26, we multiply, we have 5 times 6, 30, we need 3. 5 times 2, 10, plus 3, 13. So 130. So u subscript 5 give us 130. Then also get u subscript 4. And that's when we put 4, we have 4 into bracket 4 squared plus 1. As this here, we have 4 into bracket 4 squared 16 plus 1. That's 4 times 17. And multiply as well, 17 times 4, 4 times 7, 28. Carry 2, 4 times 1, 4, plus 2, 6, 68. So u subscript n, that gives us 68. Now, that we are finding u subscript 5 minus u subscript 4. So that's 130 minus 68. So subtract 68 from 130. Here you have 10, that's 2. Here remain 12, that's 6. So here, that gives us 62. So that's the answer here. So that's how to handle this kind of relation. Okay, now we look at another one. So give a thumbs up, share this video, and subscribe as well. So let's call this number 6. And this is unsolved. question says if root 50 is equals to, okay, root 50 minus k root 8 is equals to 2 over root 2. Find k. So this is the equation. To find the value of k. Yeah. So let's look at it together. Here we can write root 50 and the perfect square we get there is 25 times 2. Then minus k times root 8 also can be written as 4 times 2. Then equals to 2 over root 2. We try to make this sort to be in their simpler sort with 50 and root 8. And you know, when we separate this with 25 times 2, with 25, that's 5. So we can say this is 5 root 2, then minus. This is also root 4, that's 2. 2 times k, that's 2k. Then we have root 2, then equals to 2 over root 2. Now, there's a way we can find our way around this in order to get the value of k. Okay, let's do it this way to make it easier. We can bring root 2 out here. Root 2 is common. We can say root 2 into bracket 5 minus 2k. Yes, equals to 2 over root 2. Now, let's get rid of this root 2 here. And what do we do to get rid of root 2 on this side? We say multiply both sides by root 2. Multiply both sides by root 2. So here, when we multiply by root 2, we have root 2 times root 2 into bracket 5 minus 2k, then equals to 2 over root 2 multiplied by root 2. Don't forget that root 2 times root 2, that will give us 2. So that's 2 into bracket 5 minus 2k. Then here, root 2 will cancel root 2, equals to 2 now. So if you like, you can also divide both sides by 2, divide this side by 2, divide this side by 2, so that these 2 will cancel out. We are left with 5 minus 2k equals to 2 over 2, 1. Okay. Find a way out here. Taking 5 here, becoming minus 5. Here we are left with minus 2k equals to 1 minus 5. The minus 2k equals to minus 4. Divide both sides by minus 2, k equals to plus 2. So, the answer there is simply k equals to 2. All right. Thank you for connecting and for watching this channel. So, if you are yet to subscribe, and also you can share this video as well. So let's look at something here as well, which is number 7. So now, a ball gave a change of percentage error. It says ball gave a change of 68 naira instead of 72 naira. Calculate its percentage error. Calculate its percentage error. So here, there's a formula to get percentage error. You can say percentage error is given as error, and this error is absolute error. The absolute error over the actual value, or the initial value, or the intended value times 100%. Now, this error is the difference between the two. Don't forget it's absolute, not negative. So here we have 72 minus 68 over what? Which one is the actual here? A say boy gave a change of 68 naira instead of the actual change is supposed to give is 72 naira, not 68. So it's supposed to give a change of 72 naira instead of, okay, it gets 68 instead of 72. So 72 naira is the actual. So we have over 72 times 100%. So when we solve this, we subtract. So 72 minus 68, we have 4 over 72 times 100% here. So we simplify this. And that's the percentage error we have. All right. So let's look at another question here. It's an algebra. So we have to simplify x squared minus y squared over x plus y all square plus x minus y all square divided by 3x plus 3y to brackets. Now, when we simplify this, there are some things that we need to put in mind in simplification of this. So we just have to do some little changes here. This, we can rewrite this, and we have x squared minus y difference of 2 squared, that's x plus y, into brackets, also open brackets, x minus y. So that's a factorized form of this. Then over x plus y all squared. It also means x plus y times x plus y. So plus x minus y all squared also means x minus y times x minus y. Then over, I think this should be division. So that's a mistake there. That should be division. Sorry. So on the question. So here we have factor 3 out here. We have 3 into brackets x plus y. So now we do something here. First, we can get rid of this, and we are left with x minus y over, if you like, you can still put in brackets, over x plus y, and still put it in bracket. Division here turns to multiplication. This one will go up, that's 3 into bracket x plus y, then over, this one come down, we have x minus y into bracket x minus y. So now we can also, since this has changed to multiplication, yeah, this cancel each other. Also, this cancel one of these. So actually, what we have left of is 3, then over here we have x minus y. So this here is now the simplified form of that given problem. All right, I believe you are enjoying this class. This is actually the best channel as far as mathematics is concerned. So why not be part of us here and share this video and join this channel? Also, send in your gifts and thank you to support us. Now, let's look at number 9 here. For number 9, you are solving this inequality. Solve the inequality. Solve the inequality. Two x minus 5 over 2 less than 2 minus x. Now, the same way we handle equation with fractions, so we can just say this is 2x 2 minus x over 1, and the solution now we cross multiply directly here. I will say 2x minus 5 times 1, that's also same thing as 2x. It doesn't change. When you multiply something by 1, it's still that same thing. So 2x minus 5 times 1 is still 2x minus 5, which is less than 2 multiplying this, we can write it as 2 into bracket 2 minus x. Then here we have 2x minus 5 less than 2 open this bracket, we have 4 minus 2x. Now collect the like thing. Minus 2x comes here, becomes plus. So we have 2x plus 2x less than, here we have 4. Minus 5 also become plus 5. So this is 4x less than 9. 4 plus 5, 9. Divide both sides by 4. We have x less than 9 over 4. So that is that, which if you like, we can say x less than 2 number 1 over 4. And on number line, this is the middle, this is positive side. We can say this is 2 whole number 1 over 4. Here, less than, this arrow here is just looking at less than. So you are going towards the arrow. And this is the range of values. So whatever number that falls towards that side is satisfying this inequality. So that we can call this x less than 2 number 1 over 4. Okay? So let's solve number 10. So let's take a 10 question. We have, if x equals to 64 and y equals to 27, calculate x raised to power x raised to power half minus y raised to power 1 over 3 divided by y minus x raised to power 2 over 3. So we just apply the law of indices here. So that's what this question is all about. So x substitute 64 raised to power half minus y, that's 27 raised to power 1 over 3, then over y, that's 27 minus 64 raised to power 2 over 3. So now, when you apply this law of indices, that say a raised to power 1 over n, same thing as nth root of a, and also a raised to power m over n, same thing as nth root of a raised to power n. So actually, in the same way here, 64 raised to power half is square root of 64 minus, here we have cube root of 27 divided by 27 minus cube root of 64 all raised to power 2. Square root of 64 is 8 minus cube root of 27, that's 3. That's minus 3 over 27 minus cube root of 64, that's 4. 4 multiplied 3 times, give us 64. So 4 square, that's 16. Because here we have cube root of 64, 4, then square. 4 square, 16. 8 minus 3, that's 5. Then over 27 minus 16, that gives us 27 minus 16, is that 11 now? So that gives us 11. So simple, we have this as 5 over 11. So let's stop here for today. Thank you for connecting with us so far here at Master T Math Class. We appreciate you for joining us here. So do well to subscribe and share this video. And see you next class. Bye for now.